This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Good afternoon. Let's wait for a minute to let people come in before I start the review. Nobody wants to miss the review in general. And the machine, come on. Okay, let's get started. So we are pretty much at the end of the semester. I'll do some logistics before the final exam starts later in some days, and give you some key logistic information. Then we'll just wrap up the whole set of lectures, starting me today. Most probably most of tomorrow will be done by Ling, the other lecturer who has covered the first part of the semester. Okay, so without delaying any further, everybody is always curious about the final exam. So final exam is due at a certain date. For some peculiar legal reason, lecturers are not allowed to announce that date, location. You should be checking your own portals to learn the date and location, okay? How many people have checked this? Many. Anybody who did not? You should be checking immediately. I cannot announce the lecture date, time, location, but I can ask, do you know the date, time, and location? No? Well, have a guess. Yeah, have a guess, like 6th of January? No, not 6th of January. Okay. Don't fail.
6th of November.
Okay, we have a clue. Somebody said 6th of November. I didn't say it. Okay? If you didn't check, if you are not sure, please do check, okay? Questions? No? Okay, so there's a date, time, location, announced by the university, not by me. There's a good reason, I think. If there's a thunderstorm or whatever, they reschedule. So they don't want me to handle the logistics. They want the university will be updating, oh, there is this problem, so some exam is rescheduled or whatever, if need be. So they want to do the announcement. So check your portals, and if you are not sure, you can contact me, obviously. I can hook you up with the right date, time, and location. And the final exam is closer than you think. The duration, I can tell other things about the final exam, though. The duration is 3 hours, so much longer than the midterm exam. And reading time is 15 minutes. When you are, as the MIT coordinator, not only your lecturer for this subject, I should tell you a little bit about the logistics of the final exams. Final exams are not in classes like this. They are in proper exam venues, well invigilated. There is a certain start time for the reading, certain start time for the writing. Lots of students get confused with the writing time. They show up when the writing starts. They should have showed up when the reading starts, okay? So make sure you check on the exam announcement all those, where and when you should show up. Don't be late, okay? No materials are authorized for my exam, I can say that much. Meaning, not only they are not authorized, they are not needed. If there something was needed, except your pen and pencil, obviously, I would have said, I'll come to this point, I'll give you a clue. If in the exam, your results go really awkward, you need a feeling of, oh, this is like lots of maths and I should be using a scientific calculator, probably you're on the wrong track, okay? And you should not be needing calculators. Our subject is not about calculating things fast. It's about more deeper learning objectives. So no materials are authorized, no books, no calculators, and they are not needed. Yeah.
Is formula sheet provided? Or?
No, you should remember the formulas that you should remember. And if you don't remember, then you should have remembered, okay? There's no way out of this. Similar to the midterm, I can tell you, you may need, like as I said at the beginning of the semester, the book is thick. We don't cover every section. We cover the ones that I believe are important for an introductory level networking subject. So if you cover the way I covered it, the book, you read, focus on the formulas we have covered, and have attended the midterm. If you missed, that's okay. Did your assignments yourself, most importantly, tutorials yourself, most importantly, then you know what to remember, what not to remember, okay? Those are good examples, good clues of level of detail expected, okay? There are some sections we have not touched at all in the book, and in my reading, if you go to the weeks in the reading list, they are not mentioned at all, or mentioned in a different way than rather than me saying, read this, if I said quickly skim this, you get a clue, okay? Let's focus on multiple choice questions. Pretty much don't expect the final exam, an important exam, to be like multiple choice. There is lots of questions that require really solving things, okay? And prepare for that. Luckily, you have 3 hours. 60% of your final mark. That means it's a decent part of the subject, okay? And expect much more questions than the midterm. 10 to 20 questions, closer to the 20 side, okay? I generally tend to give like about 10 minutes to a question in a 3-hour exam. It gives you a rough idea of how many questions you may have. Okay. So covers, a very common question I get, the final exam covers all material discussed in lectures, tutorials, anything that appeared anywhere in the subject, you are liable to remember. Obviously, the focus was different. Okay, some material, we have solved a detailed example, okay? Some material I briefly mentioned, okay? And some material I said, well, more details are in the book. So you need different level of attention to all of these different things. The questions are spread across the weeks evenly, meaning don't assume because we have asked things in the midterm and in the middle of the semester there was a midterm, everything before the midterm is not covered. No. Starting from the beginning till the end, we cover. Midterm was more like a sample to get you prepared to the rhythm, to the type of questions and the system. And the system is very important. You don't want to be surprised with how we run exams. So you'll see final exams run similar to what I run in the midterm. I said math questions should not need a calculator. And tutorial, assignment, etc. questions are good practice questions. We have a sample exam online already. How many people know that we have a sample exam online? Very good. So you should try it, although that sample exam is some questions from other exams I have done before. Every semester I adjust our pace and focus slightly, although the main content is there. that means there may be a question or a sub-question that we may have not covered the way we have covered last semester. So because of that, the sample final exam may be slightly different. Don't get shocked. We will have one question and answer session next week as announced. So if you remember, we are 2 classes short. And well, luckily, unlike other subjects where we have 2 lectures, I insist on having 3 lectures so that we cover comfortably. Because of that, we are not really behind. So I finished on time. I missed a guest lecture or 2 that I could have used. So I reduced the remaining guest lectures for the rest of the semester, second half of the semester, to 1 guest lecture, who was here yesterday. But we are pretty much on schedule. But I will not cancel the Q&A session next week. We will have the Q&A session as announced because, well, the exam is closed. I hope you will study until then. Regardless of whether I have a Q&A session, people come and ask the questions. Why not have a Q&A session? And then we'll perhaps discuss openly each question you have. Okay. Now, I'll stop at that point for a second. And the next thing I'll announce is a survey. And I'll give you 10 minutes to fill the survey. So if you are new to this university, for every subject we run a survey. There are different types of surveys. You may have already been running surveys at the tutorials. That is for that particular tutorial hour. This survey is for everything. Everything meaning content, lecturer, all that is included for this subject. And I have to mention that especially in the infrastructure side, we did suffer dearly, including you and me. And I hear from the Central that I'll get a gift because I suffered as well dearly from the Central to remedy the suffering we had. For those who have been here a couple of weeks ago, we got lots of chocolate for the students who suffered. Anyway, so that is a key point. And if you can, differentiate this key point separately, please, and comment on that key point. I'm sure, I'm happy to at least myself take that point to the department and school head again. Make sure that lecture theater failures or recording failures don't happen as much. That is an infrastructure problem that I'm happy to follow up. I already followed up a few times, and I'll make sure I continue to follow it up for next semester, which is one of the questions, I think, in the SCS survey. So with that note, I'll give you like 5 to 10 minutes. Go to that link, and in that link, if you log in, you will find our subject. Please do fill that link. Goes to a survey, fill that survey, and give us some feedback. So I'll just, is there a door here? Yeah, I'll just wait outside while you fill and come back in 5 minutes, okay? Feel comfortable. Let's not lock myself out, though. Okay, so how many people are done? Many. So if you are not done, try to finish as quickly as possible. Any questions about the final exam? 10 people are finishing. No questions? Everybody's ready? How many people did not finish the survey? 1, 2, okay. I'll slowly start the review. I'm just conscious about time at this point. Okay, so let's look at back what we have covered. The main point of this subject is networking is tough. You cannot have one vendor, one company implementing everything, especially on a network that is as large as internet. Naturally, things have evolved as multiple vendors, multiple services that needs to be delivered, and in a layered architecture. And the architecture in particular for the internet is this architecture on the right, which is TCP/IP. TCP/IP are the protocols, but it also gave its name to this particular architecture that internet uses. Historically, actually, there is a well-established model that people have developed to guide people to write software for a network, actually for an inter-network system, and divide responsibility between layers so that a good stack of software can be developed to give service to users. Now, when you say good, what does good mean? You could have implemented all this as a monolithic system, not by the same vendor, but all together in the same layer with different vendors. Beyond vendors, different layers is important because a monolithic system is a system that cannot be changed easily, that fails more regularly, that all those things that comes with the concept of encapsulation and modular development. You have seen Java programming already. You have got the idea on programming subject, and this is nothing more than that. The same concept in computing in form of networking. You need layers to have a more sustainable system, if you will, that gives less bugs, runs, updated easily. You can change things in the services in the middle without affecting other layers, etc. So in this subject, we have covered a hybrid model, a model in between the two models. Same amount of approximate layers like the TCP/IP, the real internet, but with the OC model in mind, with a good structure. And the review I'll do today is top-down. So at this subject, we have covered bottom-up. And then I'll just start a review with top-down mentality in mind. And then Link will tomorrow cover the bottom 3 layers and finish the review. Okay? So we have covered. So let's look at some key content. What did we cover? I have all the slides with me. So the last bit we covered was about security. Okay? And we have spent a week on this. It's not part of the layers. Actual security appears in almost on every layer over the internet. A lot of focus on TCP, transport, and application layer for security. Some people, there's a history for that, some people argued that security should be at the application layer. They lost. It should be in multiple layers. And we have seen some developments on the transport layer with IPsec, for example, and network layer. So you will have some of the layers having security embedded. I have covered security as a separate topic because it's probably the topic, the hot topic of today over the internet. And you need to know some content as an IT professional, even if you don't take a security subject about internet security. So there are 4 key items to have a secure network or any system for that matter that you have the 4 areas address: secrecy of the material, who is accessing it, and authentication. Non-reputation, meaning who has created it without, like a signature, without any chance to refute the creation source. origin of a document, and integrity, not allowing the tampering of a document. So here is a key model that every IT professional, in my view, know and should know what and how encryption happens, a key topic in network security, and where it happens and how it happens, and the notation for enabling a secure message transfer. So you should know this in your heart, regardless whether you finish this subject and go to the final and get 100 or not. 100 years from now, you should also remember this concept, okay? Whether you have a final or not, this is, everybody in IT knows basically what this is. So you have some encryption happening, a decryption happening, and how it works. What's the ciphertext? What's the plain text? Ciphertext is output of some encryption happening. And some key principles, types of algorithms. A key categorization we have made. So we have seen symmetric and asymmetric key algorithms. You should definitely know the symmetric key algorithms. You don't need to know one particular algorithm in detail. We didn't cover a certain popular algorithm that is used in a certain system. We covered the mentality, how those basic symmetric key algorithms work. They substitute, transpose characters in some text, and gave some examples, but more importantly, what we covered is different extensions based on different problems that these algorithms have to be beefed up. So different types we have covered, many different types, okay? These you should know by heart. They come again and again in different contexts. The terms come again and again in different contexts. So you may have heard some of these terms like string cipher, etc. Okay? So that is a basic symmetric key-based approach. Fine, but that's not the ultimate solution. We have quickly moved into, in the second lecture that week, a more sophisticated approach, which is public key or asymmetric key algorithms. The key that you lock and the key that you unlock are different. That is a very powerful approach. And same kind of notation, but different algorithm. So this algorithm, although it's a complicated algorithm, although you may not need to come up with some numbers out of the blue, if I were to ask a question, or in the future, if somebody about RSA talks about RSA, you should be able to understand the numbers, the concepts, why it works, basically, at the level I have presented, okay? Obviously, if it is in the exam, I won't go ahead, and in real life also, nobody will give you like 100 bits and try to see whether you can cipher, encrypt or decrypt a text, okay? So you need to know the main mechanism, how this works, to be able to understand the concepts in this domain. So we have covered this example, for example, and I think I have a tutorial question on this, which shows the magic of having an encryption key, different decryption key, and it still works. And the benefit is you don't need to reveal your private key to anyone. That means a key problem is solved. If you have a private key that nobody knows, unlike a symmetric key algorithm, you are at a very powerful position. So we have seen different applications of public key cryptography to analyze how public key cryptography works. So digital signatures is one. I have mentioned how you use public key cryptography to sign a document, and pretty much addressing all those 4 key sub-areas using public keys. I mentioned the public key infrastructure, and within that context, I have talked about certification and some signature example with a private key here. And then moved on to if you see how I covered security as lectures, moved on to another sub-area in security that we have said important, authentication. Again, talking about different approaches and landing based on problems, how different approaches failed. So we have seen a few Kerberos at high level, landing on a public key-based solution, which we have discussed as an ultimate solution for authentication. Okay. Then I have discussed one key topic, whether you have symmetric key, asymmetric keys, whatever you like to think this way or that way, how and where in IP protocol some security, real implementation happens. I have discussed IPsec. Why it is important? Because it is at the core of VPN, virtual private networks. A key important topic you need to know, regardless whether applications use public-private keys or symmetric keys to lock things. Here is a case at a lower layer. You can lock things. It is well established, well used. Every IT professional should know what a VPN is and how it works. And in that context, every VPN generally works with a firewall. I have discussed what a firewall is, which is another important topic. We didn't discuss any particular Wi-Fi or wireless security protocols. They are much more recent, complicated. That's not really the focus of this subject. Although you may, if you take mobile computing, you may cover some of these. Now, going back to the one more lecture. Going back to our stack, going top down, we have discussed security, but we have discussed some layers, application layer, transport layer, network layer, and other things that Link has covered. Now, application layer is a unique layer. There is no one big protocol that everybody uses. It's not like IP, UDP, TCP. There is per application a set of protocols that comes with an application. And I have mentioned some applications in this layer. Domain name system comes with this protocol. World Wide Web, HTTP and relevant protocols. And a little bit of email we have covered. And a little bit of, because of its impact on the network, multimedia data we have covered. So among those, domain name system is probably the most important. Everybody should know in this profession what DNS is, how it works, what's its purpose, basically resolving a communicator between an IP address and a human understandable address of a host over the internet. So we have discussed key concepts of zones, root servers, key records that you exchange between servers to exchange information about domain name and IP addresses, how a URL is actually parsed, so a key, an algorithm of how you look up a particular website, different modes, iterative and recursive, and you should know all these. If you are in IT, you may be doing a network administration. Without knowing these, you won't even be able to get into the job, so to speak, although there's much more to this than just iterated recursive querying. There is a lot of subjects you can take on this front if you want to do more about networking. This is just introduction to MIT in general. So if you take distributed computing, especially if you're in that stream, you'll learn, even in distributed systems, next semester you'll learn a little bit more on this. So this is a very important topic. I have mentioned caching a bit in DNS. What else? So World Wide Web is another important application layer concept. Internet and World Wide Web are confused generally. World Wide Web is a killer app for the internet, as some say. So World Wide Web comes with a set of protocols. Given a URL, you have to connect to DNS servers to resolve. You have to have HTTP protocol to get your data from a web server. Types of different, an important topic, types of different HTTP connections. And we have run through an example of both and where it fails, why it doesn't fail, and disadvantages, especially in this slide we have discussed those. Okay, we have spent a decent amount of time in cookies, how cookies run, benefit, disadvantage, and in their comparison to having a session with or without a cookie is also possible. And also web caching, similar to DNS caching, we have web caching. This one we briefly covered, I would say. There's a lot of web caching related issues, we just mentioned a few. That wouldn't be our main topic. What else? Okay, so I have said multimedia is very important to know how it works over the internet. Two different types of multimedia delivery we have discussed. A classic type where a browser, once it gets the data, hands over to a media player, which is very lame. You cannot do streaming on this. So lots of basic model-related problems we have discussed. Very important to know. And then a more specialized model, pretty much the godfather of all browsers and how they work with multimedia data today, and the benefits of that. I have given you some algorithms for forward error correction at high level. Unless you take advanced subjects on that front, like in crypto, you do some kind of, some of these in more detail. I don't think this is the main focus of the subject. So we have discussed a little bit like verbally tornado codes. I've gone through an example. This is just extra content. I wouldn't say you have to worry about that content, but you should know what a forward error correction is. Actually, we have seen one error correction and detection related method at the lower layer. Those are the ones that are important to know. Jitter management is an important topic for multimedia. You have this low watermark, high watermark. How do you manage a multimedia buffer is very influential on how the network runs. And compression, different types of compression to achieve low, small size data with huge size of multimedia data is important for data transfer. So all these magical words, MPEG, JPEG, MP3, etc., they have a root coding, basically. There are some kind of compression algorithms. You need to know not the algorithm in detail, but you need to know the source, the need, why they work, and all these methods to call yourself an IT professional. Ultimately, you need to know, oh, MP3 is nothing more than actually some version of MPEG, which was, some people agreed on a format to compress video data, and MPEG uses based on perceptual coding, for example. What is perceptual coding? You have two types here we discussed, so that you know the main idea of how things in audio or video are compressed. Okay, so and the last application layer set of protocols we have discussed is related to email, which is another important killer app for internet. And components are like a user agent, transfer agent, and a set of protocols to transfer messages in between. There are two types of protocol, this SMTP between transfer agents mostly, and also the source of the email. And receiver uses two different types, POP3 and IMAP. They have all their benefits and disadvantages. I've given some of these here, so you should know why do this way or the other way. Okay. And I actually remember that we have covered the missing layers of the OC model briefly, which is presentation and session layer. So in this, you need to know the services related to each layer. So I mentioned key services. For example, session layer needs to do authentication. They are all embedded in applications today. So application layer is a big fat layer over the internet. Although in the OC model, there are these specific layers that deals with authentication, etc. And my advice from this lecture is if you are considering a networked application, keep these layers separate as well. Create these virtual layers in your software so that you don't build a huge piece of software that deals with authentication, I don't know, multimedia encoding, everything all together in one big monolithic piece of code. So I mentioned P2P systems. It's a good example. You don't need to understand this algorithm, for example. It was a good example to mention that people, when experimenting with P2P systems, have come up with those layers as well, okay? So those are the layers. When you write a P2P system, people implement session layer, presentation layer, before they implement application layer semantics. Okay. So, before, I guess. So somewhere here, yeah, that is the one, last one. So, okay. Transport layer is a big, important layer. Another important layer, I would say, network layer. You should expect lots of questions in life and in the final exam from transport layer and network layer, because we have spent lots of weeks. In real life, if you are implementing code, you'll spend lots of weeks writing code on the transport layer. You'll see in the distributed system subject, this is the most important layer you communicate with and do lots of debugging as well as coding. So the main function is give, I highlighted keywords here, from a practitioner's point of view, reliable, from process to process communication independent of lower layers, and it sits on top of the network layer. So there are some addresses for applications that are pretty much processes to communicate and hook up to each other over the network. You need to know these are pretty much ports. There are different types of those addresses, and key function of the transport layer is know how to bind different processes and addresses to each other. I have given you an example of how to write code using transport layer. If you are going to write your application, you are going to use something called a socket to access at a port, at an IP address, a certain process on a different machine. You need to understand this code, but I repeat, in this subject, I won't ask you, oh, given a client software based architecture for, I don't know, doing some mathematical computations on a server, write the client and server side programs using Java sockets. I won't ask that in the final exam. That is type of projects you'll do in the distributed system subject, although you need to understand what a socket here in this subject is, okay? And looking at the code will help you. The code in the book is not a very good code. I mean, in the sense that it's good code, obviously it runs, but before we jump into that code in detail, I suggest not to jump into codes online or here related to Java, because you have studied Java that aligns with our curriculum better than the code in the book. So I have written in Java kind of looking language, although try to be language independent. Every language will have the concept of a socket. Every classical programming language, so to speak, or popular programming language that will have a socket concept. You will be able to write client-server pretty much in every language I know, similar to these lines of code that I write here. They give you certain services, and there's lots of primitives matching to those services. A key concept in this subject you should realize, whatever data is being passed on the wire, from even the highest level to the lower level, it comes in units, okay? You don't pass one big video file as a big file over a physical wire, for example. You divide it into pieces. At the transport layer, we call it segments, and next layer, lower layer, packets, then frames, etc. The point that people regularly get confused when I give questions or in real life, they put segment to this one, packet generally they put in the middle regardless, and frame into the inner one. Don't forget, if your data is coming from above, from the application, divide it into segments, then put into, with a segment header, into this small package. The next level will take this and put it, encapsulate it into another package. So actually, packets and frames, the lower level services put things around, not inside, okay? So don't get confused. That's a very good point to get confused. Many people do get confused there. Okay, we have discussed different issues with connecting and disconnecting, very important topics. You need to know certain things about the transport layer on the internet, okay, the main protocols, TCP, okay, and then how does connection work, how does connection release work, okay? So problems the three-way handshake protocol solves. Problems with the connection release, the generalization of the problem. Every IT professional knows what a two-army problem, okay? So those are very important topics. Okay, so connection release based on three-way handshake we have covered. And those addressing types, further programming about sockets, especially over time what steps happen. Once you know how to connect, you can trace these steps between client and server. And I have discussed this, especially this part. I would not ask a question about multi-threading. That is beyond this subject's context. You need to know there's something called multi-threading to understand that each client request does not need to be done in a sequential manner slowly. You can, in parallel, serve requests. That is done through something called multi-threading. If you get the general concept here, that's fine. Not the coding part, okay? That is the job for next semester. And I have taught distributed systems. That is a point you suffer dearly, basically. You will debug a lot of debugging waiting you next semester for that particular, this set of lines. Okay. So what else? Important stuff. UDP is a protocol you need to know. Why you have UDP? On top of IP, something without a connection exists called UDP. Why? Definitely an important topic that everybody should know. Where it is used. Again, not much into coding. You may want to know about this for your general benefit, but we don't need to really prepare programming for our exam, or until you finish this degree, you don't need to know programming at the end of this semester with sockets yet. Okay, so this is a point I get lots of questions. Do I need to know these fields also in TCP? So I'll show you also this one. And the UDP and TCP protocol comes with certain headers that they put in front of the segments. Unfortunately, you need to know this. If I cover such, not only for this particular figure, if I cover such a figure, loss of flags, if link has covered such a figure at data link layer or network layer headers, there is a purpose for each of these things, why they exist, okay? They are important. A networking person should know them, okay? Unfortunately, you need to know them. For not only TCP, for all of UDP and lower layers. We have spent quite a bit of time on this. Okay, very detailed transmission connection example with TCP here with Windows. And I have spent a decent deal of time on talking about congestion control. And a question I get here is people get confused when I discuss congestion control about a special transport layer. They think everything is done at transport layer. It is not. Some of these algorithms at the network layer, I have mentioned which ones are in the transport layer, which ones are in the network layer. But increasingly, I said transport layer has a big role for network congestion because it controls the endpoints, how much traffic is being injected. So given something like this in real life or in the exam, you should be able to make a deduction, okay? You may be fearful about making a judgment. Make a judgment. I don't generally deduct as many points as you think. I don't deduct like, oh, there's this bucket wrong, 0. I don't do that. I try to understand what the person thinks per the whole row to make a judgment, okay? So generally, solutions for a particular application on one front comes from another column. So you can have high, 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 but one column needs to be low to get the others high. So those kind of correlations are important. Okay, lots of techniques we covered on quality of service and congestion control. A very important technique is basically TCP Tahoe and TCP Reno that uses additive increase, slow start. Unfortunately, you need to know the details of these, the differences, why they are important, which one works, which one was the upgraded version and why. Is that it, pretty much? Yeah, that is pretty much it. We have covered the transport layer, and before the transport layer, we had a midterm, and before the midterm, link covered network layer, data link layer, physical layer, and then you have covered pretty much all the layers that exist over the internet with key topics that you need to know, key algorithms you need to know over the internet, okay? Now, one last question that you may ask before we go, I want you to know. Many of these algorithms come with different names or how they are referred differently in different books. Like, I didn't use the term Nuggles algorithm, okay? We have used certain terms in the slides. In the exam, I will use mostly the terms that I use to refer in the questions. I refer to certain topics, right? So those are the terms that you should expect. There are lots of other terms and abbreviations that I did not emphasize. Those are less likely to bother you, okay? A very big problem in this subject is there's so many abbreviations, so many terms, and given that we covered, I don't know, almost 900 pages, you don't need to memorize all of them, okay? In real life, though, people may refer to something we covered as Nuggles algorithm, okay? You type in Wikipedia what is Nuggle, and you see, oh, I've seen this algorithm. It's not a big problem, okay? Tomlinson's algorithm, those things, some people use those names, the name of the person who had first invented a particular algorithm we have seen. Anyway, with that note, I'll stop. Tomorrow, Link will be here. We'll continue the review tomorrow with Link's review. And next week, we'll have a question and answer session. Please try to finish your final exam preparations by that time, at least the bulk, so that you have good questions. Thank you very much. Thank you. Sure. Let's go out actually. There may be a lecture. I'll be around, so I answer questions, okay?